Hello everyone, welcome to the session. So in this particular video, we will talk about another yet interesting data structure named as stack. So until so far, we have seen a lot of different kinds of data structures, and we have seen that at what point of time, which data structure is preferable. So let's talk about the same thing in this data structure as well. The name of this data structure, as I told you, is stack. Now, by saying stack, the only thing which should come in your head is something called as LIFO. What is the full form of this term called as LIFO? I hope maximum students already know about that. It is something which I would say as last in, first out. What is the intuition behind that? I'll let you know in a meanwhile. So basically, I would say that this is a kind of a data structure where we will try to store the data in such a way that whichever data will come at the very end will go very first. Whichever data will come at the very end will go very first. The very simple example I can give you is so suppose you are going for a party or a team lunch, and you will be seeing a stack of plates at your dinner, right? So at that point of time, if you will observe, the waiter who will put the last plate, then the consumer will go there and will pick up that plate as the very first. That is what we usually say, stack of plates, stack of cubes, right? So internally, whenever the stack is there, LIFO kind of architecture will come into picture, wherever whatsoever data that we have that is going last will come out the first. Or in other words, you can also say it as FILO, FILO. First in, so whichever will go first will come out last. You can also say it first in, last out, right? But usually it is famous by the name of this term called as LIFO only, not by the other term, but it's one and the same, I would say. Okay, now with this data structure, if someone is asking to you what are the ADTs of this, what is the ADT? Means abstract data type. What is the meaning of that? The simple meaning is that what kind of operations you will perform in this data structure. So there are mainly two operations that you will do in any stack based data structure. One is the push operation. So very simple, push operation is simply used to insert the elements, inside the stack, right? So this is the first operation that stack will do, and the second operation that you can perform in the stack is pop, where you can simply try to delete the elements from the stack, right? So these are the two important operations that we usually perform inside a stack based data structure that we have, push and pop. Okay, I hope that this is making sense to everyone. Now, let's further move ahead. So whenever we are talking about a stack-based data structure, let's talk about that how the push operation that we are seeing here will come into picture. So there is something which we have called as top variable you can take, which is basically used to store inside the stack data, and whatsoever be the data which will coming at the very end will store at the very top position. That is the internal intuition behind this variable. If I will try to give you one real-time application of the stack data structure, maybe I can show you practically as well. So what I can do here is that I can maybe directly go to Google Chrome, and suppose in this Google Chrome, I am typing the LeetCode platform, leetcode.com. Suppose I am going here. After that, I want to go to explore part. So first of all, if you remember, I went to the leetcode.com. After that, I went to this explore part. So let me write it side by side so that we didn't, forget these things. So what we are trying to do here is that, first of all, so everything, whatsoever you are doing in the URL, you are storing inside the stack, suppose. So inside the stack, what will happen is that, first of all, I am saying that we went towards the LeetCode platform. So if you will observe, there is a website of leetcode.com, right? After that, I went towards the explore. So there is something which we have, leetcode.com / we came towards the explore part. Fine. Now suppose I am not satisfied with this explore part, and what I will do here is that I will go towards the problems. So now this is the URL which I will be able to get. Can I copy this in the PDF? I'll try to do this thing if I can, but I am not sure. Okay, so I can. So this is the second thing. So let me do one thing now to make it in a better sense. So this is the next thing which I am doing here. So I am going to this link, right? Before that, if you will observe, so firstly we went to leetcode.com. I copy that and I will paste it again here only. So what I can do is I can just remove this part as well, and I will try to copy this. Perfect. So first of all, I went to the leetcode.com website, right? After that, let me erase this as well because this is not looking better to me. That would be a much better thing that we are doing now. So let me increase the space further. So here, right? Firstly, we go there. Then the second link which I am traversing is the explore part. So I will copy this explore part as well, and I will try to paste it here. After that, if you will observe, so we will went to this explore part. That is also done. After that, if you will observe, I am going towards the problem set. And after that, suppose I went there. And after that, suppose I will open some problem called as TwoSum problem. So I will just copy the URL of this as well. So every URL, I am trying to save it inside the stack. That is what happening here. You can clearly observe, right? Okay. I hope everyone can easily able to see this. So this is something where one side is closed, another side is open for the entry purpose. This kind of data structure is something which we are calling it as a stack data structure. Here, the top is the variable which will point to the topmost value. So as of now, this is the top pointer that we have. Now, what will happen? Suppose you want to go back. If you will want to go back, what will happen? You will always see that you will go back to the previous link that you have opened. Let me show you. I will go back. I went to the problem set all link. That is what happened because this is there inside the previous thing. If I will further go back, you will observe that I will go back to the previous link of explore part. If I will show you the demo as well, you can see I am going towards the explore part, right? If I will further go back, what will happen? I will go towards the where I started. This was the last link, first link which I opened. So this was something which will come out last. So if I will go back, you will observe that this is something which is the last part which I have opened. So basically what I am saying is that this is the very beautiful application of stack data structure, and we all use this kind of application in the URLs, right? We always have a habit to open the URLs simultaneously, step by step. So internally, when we will click on the back button, it will be able to open the previous URL. This is all happening with the help of this stack-based data structure. Apart from that, if suppose I will show you some feature, for example, of an undo feature. I hope everyone knows this feature, which is something when you tap Ctrl+Z in Windows, the content whichever was there in the previous whatever you have written will come. Meaning what I am trying to say here is that suppose I will try to open maybe Jupyter notebook here now. So I will try to open the Jupyter notebook here. So let me try to do that. And we'll try to see. Anyhow, I know that maximum students know how we can use the undo operation. But once we usually see the things, visualize the things, then I think we get a better sense. And that's the only objective of showing everything here. So let me open this. So for example, here, if you will observe, if suppose what is happening here, let me open the new notebook here. So suppose I will just remove these two things, okay, inside the stack. Now, what will happen is that if I will tap Ctrl+Z, whatsoever things I have just removed will automatically come up. Now, if suppose I will just remove firstly this, then I will remove this, then I will remove maybe this. Now, what will happen is that, first of all, which particular parameter will come? Whichever thing you removed at the very last, which was stack initialization, that will come first. Then the middle one, then the last one. So what I want to convey here is that I want to simply convey one very simple thing here. That is that whenever you are applying Ctrl+Z, means whenever you are doing an undo operation, again you will observe that the LIFO kind of structure is happening there as well. Can I say? I just showed you with the help of a demonstration as well. Why I did demonstration of everything? Because I want you all to have everything in your head if you will go out of this session after that as well, right? If someone can ask you the scenarios, the examples, real-time applications of this data structure, I hope that now you can convey that, right? Okay, so let's get started with the in-depth intuition behind the pushing part. Like how basically we will be able to push the data inside the stack. Another very beautiful application before moving to that part is the function callings. I hope we already have seen a lot of, examples of recursion, right? So in function calling, wherever you will observe that recursion is there, right? There is a lot of function callings which will happen. And in that, I always said that function calls will be stored inside the stack-based data structure. So it will basically try to store all the function calls inside that, and step by step it will try to execute the functions and will go back. So you will observe that whichever function called at the very end will be executed at the very first end, right? So function calling again is a very good application of a stack-based data structure. Now, whenever we are talking about a pushing part of in a stack, how basically push operation will be done, let's try to understand that part. So what will happen is that suppose you want to push. So before that, you should know that the stack can be implemented with the help of two data structures. Either you can do the implementation of stack using the arrays, or you can do the same thing with the help of a linked list, right? Either you can do with the help of arrays, or you can do with the help of a linked list. Now, the question is, which one is more preferable and why? So specifically talking about in Python, when I'm saying stack is executed in arrays, it means we are talking about a list. Can I say? And in Python, we usually have a concept of dynamic list only, or I would say dynamic array only, where we can append as much data as we can, but how internally things will happen, I hope everyone is already aware about that. So usually, if suppose you will be having a list or the array of size 10, and so let me try to create that 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Suppose I have created this kind of a list. Now, after creation of this list, what will happen? What will happen? So, it will try to mainly append the data automatically if you want to insert the 11th element. So, suppose insertion will happen here, then here, then here, then here, here. All these things are done. But after that, automatically when you will try to insert the data at the very next position, you don't have the space. So what dynamic array will do, it will not give you the error like out of bound or out of index kind of thing. What internally it will do is that, so initially your list or your array capacity is 10, can I say? So it will try to create a new list which is of capacity 2 times the initial capacity. Can I say? So it is something where it will start from 0. It will start from 0 and I would say it will go until the value of 19. So 0, 1, 2 until the value of 19. So here what usually happened is that internally automatically it will try to do 2 times, twice. So initially the size was 10, now it will become automatically 20. So the capacity is something which is equals to, I would say, 20 here, automatically, right? And then what will happen? First of all, there is a copying of data, copying of all the data from the original array, right? And after that, append will happen to the 11th element. So this is a very costly operation and it will take a lot of time, right? First of all, though, we are creating a huge space separately. After that, what we are trying to do is that we are first of all trying to copy all the elements that we have. And after that, what we are trying to do is that we are trying to then append the new element that we have. So in a way, what I want to convey here is that whenever we are talking about a stack-based data structure, it's usually preferable to go for a linked list kind of a thing where there is not that contiguous memory allocation scenario will be there. We can store data at any point of time, anywhere. It's just the pointers game. We already know that. We already have completed the linked list portion in a very much depth, right? So that's why whenever we're talking about stack-based data structure, linked list is preferable. But by saying that also, we will need to study both of them, right? And we will see the implementation also for both of them. So whenever I'm talking about the push operation inside the stack, so how basically it will be done with the help of arrays. So suppose you will be having a push function, you will be having the array arr and the data that you want to insert is this data. Now what you will try to do here is that you will first of all see that if suppose you are dealing with a static kind of array, then what you will observe is that if the value of top pointer is equal to, is that reachable to the value of n or not, where n is the size of the array that you need to define. By saying that, I am saying that here we are dealing with the situation of a static array. But in Python, we don't have that concept. But in other languages, you have that concept. So there is a condition that we called as stack overflow at that point of time. But in Python, that condition won't happen because, as I told you, the concept of dynamic array is coming into picture. Now, if suppose that kind of thing will never happen, then what will happen? First of all, you will try to increment the value of top, which is equals to top plus 1. As I told you, that top is the variable or the pointer which is taking care of the number of elements that we have and will always point to the topmost value which we have inside the stack. After that, what we will try to do is that we will take the index of that top value and will try to store the data inside that particular thing. And that is how I would say the storage will happen inside a stack data structure. This is how basically the push will happen. So if you will observe here, what we are trying to do is that we are just trying to update the pointer of the top variable that we have, and then we are trying to simply push the data inside the array data structure. So here if you will observe, if I will talk about the time complexity of doing this task, then can I say that it is nothing but is equals to big O of 1? Means, can I say that it is a constant time operation task? Constant time operation task? Can we say? Right? So here we are simply trying to push the data by just updating the pointer. We are nowhere using any kind of a for loop. Nothing like that is happening here. Right? Similarly for a linked list as well, but instead of using an array, there we need to create a specifically linked list. And how we can create that, we all know. For that we need to create a node which contains the data as well as the pointer, the next pointer which you can say. Correct? So with this, I would say that simple pushing operation will happen inside a stack-based data structure. In the next upcoming video, I will talk about the next operation which we have is the pop operation, right? And after that, we will try to see the implementation of this data structure using both of the vectors, using arrays as well as using a linked list. With this, bye-bye everyone. See you all in my next upcoming video.